A very unusual object is currently traveling past our sun. Its true nature and purpose remain a mystery. In fact, we can no longer see it at all. For months, this object has been under intense observation. It has been named 3I Atlas and classified as an interstellar comet. A great deal is already known about this new visitor to our solar system. In just 4 months, nearly 100 research papers have been published about 3I Atlas, with even more unofficial information circulating, some of which sounds quite extraordinary. Today, we will sift through all the speculation and uncover everything you truly need to know about 3I Atlas. Let's begin with its journey. Right now, 3I Atlas is making its closest approach to the Sun, a phase known as perihelion. This peak occurs on October 29th, when it will pass approximately 210 million kilometers from our star. In space, we often use a larger unit called the astronomical unit, or AU, which is the average distance between Earth and the Sun. This helps us grasp the scale of our solar system. 4 AU from the Sun, placing it just inside the orbit of Mars. This period marks its peak activity, as it will be at its hottest, causing significant material to blast off its surface into space. This process is normal for a comet and is called sublimation. In the vacuum of space, solid material can transition directly into a gas. Sublimation gives a comet its distinctive appearance, a fuzzy halo known as a coma and a long tail. The coma is made of ejected gas and dust, while the tail is formed as solar wind. A constant stream of radiation from the sun blows the lighter particles away from the coma. It's a beautiful cosmic display. Unfortunately, we cannot observe this happening with 3I Atlas during its peak exposure to the sun, because our view is completely blocked by the sun's glare. We know where 3I Atlas is and what it's doing. While we wait for it to reappear, let's explore how it got here. This story is deeply fascinating. Tracking of 3I Atlas began in July 2025. It was officially spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes in locations like Hawaii, Chile, and South Africa. These telescopes scan the night sky for moving objects. On the night of July 1st, they detected just another moving object and initially classified it as a new asteroid. However, they soon noticed something peculiar. It was moving far too quickly. Everything in space is in motion, with objects in our solar system orbiting the sun, held by its gravity. The closer you are to the sun, the faster you must move to avoid falling into it. Move fast enough, and you can escape the sun's gravity entirely, flying out into interstellar space. When astronomers measured this new object's velocity, they were shocked. It was the fastest moving object ever detected in our solar system. For perspective, Earth orbits the sun at 30 kilometers per second. 4 AU orbits at about 48 kilometers per second to avoid falling in. 5 AU from the sun. At that speed, it was clear this object would swing past the sun and keep going. This is called a hyperbolic trajectory, meaning it originated from interstellar space and will return there after its tour of our system. This is how it earned the name 3I Atlas, designating it as the third known interstellar visitor. The first was Oumuamua, which was strange in its own way. The second, often overlooked, is 2I/Borisov, which behaved surprisingly like a normal comet. There are three major differences between 3I Atlas and its interstellar siblings. First is size. It is much larger, 6 kilometers wide. Second is speed. Atlas travels at about double the velocity of the previous two. Third is its direction of approach, which is the strangest part. Oumuamua came from above, from the northern sky, which is generally the direction our solar system is moving. Borisov came from a similar general direction. 3I Atlas, however, did not come head-on. It came in at a side angle, almost perfectly aligned with the plane of our solar system. Our solar system is like a flat disk, called the plane of the ecliptic. Most objects orbit within this plane, with a few exceptions like Pluto, whose orbit is tilted by 17 degrees. 3I Atlas is only 3 degrees off from this ecliptic plane. It hit our solar system in near-perfect alignment. Given the three-dimensional vastness of space, such a precise side-on approach is a remarkable coincidence. This leads to a bigger question. Where did 3I Atlas come from? We know it came from the direction of the galactic core. If you look at the Milky Way from above, we are located in an outer spiral arm. The Milky Way you see in the night sky is the next arm over. 3I Atlas came from the direction of the bright, star-packed core. But space is three-dimensional. To understand its origin, we need a side view. Like our solar system, most material in the Milky Way is concentrated in a thin disk around the core. However, some material exists above and below this thin disk, in an area called the thick disk. This region is less crowded, with fewer collisions and stellar explosions, allowing objects to remain undisturbed for billions of years. 6 billion years, nearly twice the age of Earth. We may never trace its exact origin point, but astronomers have backtracked its path over 10 million years, identifying 93 stars it passed near. 3 light-years, or 63,000 AU, 4 AU from our Sun. Let's discuss how 3I Atlas approached the Sun and what we learned. Although officially discovered on July 1st, it was first spotted on May 7, 2025, by the Transiting Exoplanet Survey Satellite, or TESS. For about a month, TESS happened to be looking in its direction, allowing us to track it as it moved through Jupiter's orbit. Astronomers first measured its brightness over time, which reveals composition. They use the term flux to describe perceived brightness. For example, the Sun appears much brighter from Mercury than from Earth, though its actual brightness hasn't changed. Only the flux has changed. 5 between May and June as it moved about 1 AU closer to the Sun. However, TESS data showed the flux increased by a factor of 5, a massive jump in reflected light. This told us it wasn't an asteroid. It was a comet beginning to form a coma of gas and dust, which reflected the extra light. 2 weird things emerged from this observation. The first involves light polarization. When sunlight hits the gas and dust cloud around 3I Atlas, it scatters. If light scatters sideways at a right angle, it's called positive polarization. If it bounces straight back, parallel, it's negative polarization. Most objects in space, including interstellar ones like 2I/Borisov, show positive polarization. 3I Atlas shows extreme negative polarization, the most extreme ever recorded. This is strange and suggests that what's normal in one star system can be weird in another. The second surprise was that the coma existed at all during the May-June period. At that time, 3I Atlas was still beyond Jupiter's orbit, over 5 AU from the Sun. It's extremely cold out there. Comets from our solar system, typically made of water ice, usually don't form comas until they are between 3 and 4 AU from the Sun, when sublimation begins. But observations with powerful telescopes revealed that 3I Atlas's coma was dominated by carbon dioxide gas, with some water vapor at a ratio of about 1 C/Otwo to water, the opposite of what we usually find. Think of dry ice, frozen C/Otwo used for stage effects. It sublimes at very low temperatures. That's what 3I Atlas was doing far out in space, explaining its early coma formation. As it approached the Sun, we watched this ratio flip. 5 AU, it began releasing a massive amount of water vapor, equivalent to a fire hose at full blast, more than expected from a normal comet at that distance. We've never seen so much water vapor appear so suddenly. The same sudden appearance happened with metals in the coma. Over the summer, astronomers detected nickel but no iron. Nickel and iron are commonly found together in the universe, as they are forged in dying stars and spread by supernovae. Finding one without the other is puzzling. Furthermore, it's strange to see any metal sublimating at such a distance from the Sun, where it's still very cold. The leading theory is that the massive C/Otwo release dragged nickel atoms along. This still doesn't explain the lack of iron. By late September, iron finally appeared, and the nickel-to-iron ratio shifted to a more normal combination. So 3I Atlas is becoming more normal, but in a very strange way. Now let's talk about tails. Here, too, 3I Atlas behaved differently. When a tail first formed around it in the summer, it was pointing toward the Sun. This is unusual because a comet's tail typically points away from the Sun, pushed by the solar wind. The early Sun-facing tail might be related to the early coma formation, driven by high C/Otwo concentration. At such a great distance from the Sun, the solar wind may have been too weak to push the gas and dust cloud away, allowing it to accumulate on the Sun-facing side. Eventually, by September, a short, fan-shaped tail facing away from the Sun developed, which is normal. Not all comets have long, streaking tails. Tail length varies based on composition and distance from the Sun. 9 AU away, half an AU closer than 3I Atlas will ever get. Our closest observation of 3I Atlas came not from Earth, but from Mars. 19 AU of Mars, the closest it will come to any planet. We are fortunate to have many cameras on and around Mars. The Perseverance rover captured an image from the surface, showing the object as a streak in the night sky after stacking several long-exposure images. The European Space Agency's ExoMars orbiter also captured an image, providing a clearer but still low-resolution view where the bright coma and the object's surface cannot be distinguished. For finer detail, we would need an image from NASA's Mars Reconnaissance Orbiter, which has the most powerful telescope at Mars. Government shutdown at the time this video was made. That image may not have been taken or released. Time is on our side, as the Sun will block our view of 3I Atlas until early December. We will then be able to study the Sun's effects on it. Its closest approach to Earth will be on December 19th, at 1 AU, by which time it will be well on its way out of the solar system. 36 AU of Jupiter. While we don't have as many cameras at Jupiter as at Mars, the Juno probe, which has been observing the gas giant for a decade, will have a chance to take one last image before 3I Atlas disappears. At that distance, the object will be cooling down and becoming less active, but it may have been changed by its exposure to the sun, adding another layer to our understanding of interstellar objects. It's entirely possible that many of its strange characteristics were not present at its formation, but were accumulated during its long journey. For now, we can only wonder, but more answers, and undoubtedly more questions, are on the horizon. If you found this journey through the cosmos fascinating, please support the channel by subscribing, liking this video, and sharing it with others who love to explore the universe's mysteries. Your engagement helps bring more content like this to light. Thank you for watching. The Juno probe, which has been observing the gas giant for a decade, will have a chance to take one last image before 3I Atlas disappears. At that distance, the object will be cooling down and becoming less active, but it may have been changed by its exposure to the sun, adding another layer to our understanding of interstellar objects. It's entirely possible that many of its strange characteristics were not present at its formation, but were accumulated during its long journey. For now, we can only wonder, but more answers, and undoubtedly more questions, are on the horizon. If you found this journey through the cosmos fascinating, please support the channel by subscribing, liking this video, and sharing it with others who love to explore the universe's mysteries. Your engagement helps bring more content like this to light. Thank you for watching.